2.7 Continuity with variables. Okay, let's get started. First thing, let is write down some things that makes a function not continuous. So things that make it discontinuous. And we've been speaking about this for a while now. So number one, remember there are holes, there are removable discontinuities, removable. Okay, number two, there are asymptotes, vertical asymptotes only. That is an infinite discontinuity, right? An infinite discontinuity. Three, remember the last thing are jump discontinuities, jump discontinuity. And remember those occur with piecewise functions. We only see those on piecewise functions. Okay, let's go on to the next slide here. Okay, we're going to be finding k values. So this k value right here that will make this function, this piecewise function, continuous. So remember, you got to remember your three rules of something being continuous. The first rule being that the limit exists, and here I'm going to write them down here. First rule, the limit as x approaches whatever value of our function exists. Number two, there is a point, that the point exists. And number three, that they're both equal to each other, right? Okay, so what we're going to do here is I'm going to try to make the limit exist, which means I want to set the left-hand side equal to the right-hand side so that the limit from the left-hand side, x approaches -2 from the left of our function, is equal to the limit as x approaches -2 from the right. Now that will make number one be true. So let's do that. K x minus 4 equals x cubed minus x. And we are checking the value at -2. So let's plug in -2 for our x value. So -2 minus 4 equals -2 cubed minus x. Okay, now let's just solve for k. You have, oh, I'm sorry, x, not x right here, -2. Oh, man, the pen messed up on me. That's a -2. Okay, now we're just going to be solving for k. So we got -2k minus 4 equals -8, and then negative and -2 make +2. Okay, so we got -2k minus 4 equals -2 plus 6. -8 plus 2 is going to be -6. And then just solve for that. So -2k equals, at the 4 over, that's going to be -2. Divide by -2 on each side, so k is equal to 1. So if you put a 1 value right here, that would make the limit from the left and the right equal each other. So step 1 would be good. Now look at step 2. Does the point equal the limit? Or is there a point? Yes, there is a point because it's equal right here. So we're using this function, which we just made it equal to the limit. So step 3 is also complete. So we did step 2 and step 3 by just setting the left and the right equal each other. So a k value of 1 makes this whole thing continuous. Any other value makes it not continuous. So same thing over here. We're going to do, if you notice, we have the exact same stuff going on here. To make the limit exist, we need to set the left side equal to the right side. Yeah, so k x equals kx squared minus 7. Okay, we're plugging in 3 for x. So k times 3 equals k 3 squared minus 7. That's going to give me 3k equals 9k minus 7. Subtract the 9 over, so it's going to give us -6k equals -7. So divide by the 6, we get 7 over 6. That is the k value that's going to make these two functions equal each other out. So that the first step, the limit as x approaches 3, does exist. Now notice it also has an equal sign, so it also checks marks the second step, which is the point. And then if you did that, I mean, we made them equal each other, so check marks all 3 steps, and it would be continuous. Any other value other than 7 over 6 would make this not continuous. Okay, I got one more example here. It's just a little bit more difficult. I'll explain why right now. Notice we are doing the exact same thing. We're going to set the left-hand side equal to the right-hand side. So left-hand side equal to the right-hand side. It's going to be k squared times 2 because I'm plugging in 2 for the x value, equals 2k 2 squared minus 6. I plugged in 2 for all the x values. Now we got 2k squared equals 4 times 2 is 8k minus 6. Now, you're trying to solve for k, and you see a k squared. Remember, that is the sign to move everything over, so we can have 2k squared minus 8k plus 6 equals 0. Remember, we're setting equals 0 so we can factor stuff out. Remember, so we can do this equals 0, and then you can set each factor equal to 0, and you have 2 answers. Now, what I notice here is that each one of these things is divisible by 2, so that's going to be my first step. I'm going to factor out a 2 so I don't have to deal with that number that's in the front. Okay, so I'll have a 2 right here. Factoring will leave me with a k and a k. Looks like my factors will be 3 and 1. And it looks like I need both to be negative in order for me to get a negative 4 and come out with a positive 3. So, it looks like we have k minus 3 equals 0, k minus 1 equals 0. So we have 2 answers, 3 and 1. So you can either put, for the k values here, you can either put both of them as 3, and that would make it continuous, or both of them as 1, and that would make it continuous. You can't use like a 3 on one of them and a 1 on the other. That's not gonna make it continuous. That's gonna make it discontinuous. So we have 2 answers in this case. K can either be 3 or 1.